Okay, so I'm going to get started. My name's Nigel Parker. I'm the Chief Technical Evangelist for Microsoft across Asia Pacific. I live in New Zealand, which is pretty much as far as you can get from Norway. But I'm kind of here on a bit of a pilgrimage because Norway is one of the places that I've always wanted to visit. And when I met the team down at NDC in Australia in Sydney, I really felt like I wanted to come here and experience NDC Oslo. So thank you for having me, and thank you for coming along to the talk today. So the way I'm going to approach the talk, this is a little bit like a life hack. It's a journey that I've been on over the last 4 or 5 years. So I'm going to share my story, and then what I'm going to do is dive into what I've built and take you through the components of the solution. And my hope is that you'll be left with ideas on how you could apply some of these techniques to yourselves or use some of the concepts that you see here in your own lives. I'm going to let you in on a little secret. I believe that you can change your life through insights from data. And I hope in the next 1 hour, I'm going to be able to take you through my story and show you how I've been able to achieve just this. I was listening to a TED Talk recently by a guy called Drew Dudley from Canada. And he talks about this concept of everyday leadership. And he talks about this view that leadership is not equal to changing the world. And he feels that we spend too much time celebrating the things that hardly anybody can do. We talk about Elon Musk and SpaceX and launching the space rocket into space, bringing it back down on the same platform and launching it again. Now, that's an amazing accomplishment. But if we measure all of our accomplishments against those kind of things, we're going to find ourselves in a position where we convince ourselves that the only things that are worth celebrating are those massive achievements. In fact, it may mean that we start to devalue the things that we do every day. And when I've started talking about my story and the process I've been on, I've actually met a bunch of people who have been inspired by this. And I get inspired when they come back to me and talk about the changes that they've made and how they're implementing it. And I believe that everybody in this room is working on technology as developers or engineers, building solutions that are worth sharing. So I hope out of this talk that you'll take some of those ideas and concepts and maybe publish them on GitHub or take them to a meetup or start to talk about things that you think other people would be inspired by or want to share along as well. In the keynote yesterday, when Dylan Beattie was talking about the history of computing, he talked about where computing has come from in the early days. What he didn't touch on was the story of Joan Clark and Alan Turing during the Second World War. And the reason I wanted to reference this example is because I think this was the first time in human history where we had people who added skills to augment machines to solve problems. So when they cracked the code, a lot of that was human intelligence. It was understanding that there was a call sign, that the weather was being read first thing in the morning, and then it was the machine that was actually doing the calculations to break the code and to be able to decipher the messages. So I think it was an early example of humans plus machines. I also believe that data is art. The world around us and everything that we live in is constructed through this idea of data. And what I mean by that is as humans, we're hardwired to find certain proportions and spatial relationships more pleasing than others. And a lot of this happens unconsciously or unbeknown to the person themselves. And what I mean by that is there might be a photograph or a piece of art that the majority of people find appealing, but you may not quite know why. In photography, there's this rule which is called the rule of thirds. And when you take an image like this, you might look at that photo and think that's aesthetically pleasing. But when you decompose it to the rule of thirds, you put the grid system around it, you can see that the proportions layout is what is making it pleasing on the eye. And inside of nature, this number here, anyone know what this is? 1 to 1,618. So this is the golden ratio. And if you think about ourselves, how our body's constructed, a lot of things in nature are built around this concept of the golden ratio. From mollusks that we see down in the sea to ourselves. And it's A plus B is to A as A is to B. So that's the proportional formula that makes up the golden ratio. And as humans, if I put my arm out here, this is built on the same premise. So if you put your foot up to your forearm, the distance from your heel to your toe is exactly the same as from your elbow to the base of your hand. Your knuckles are built out based on the same principle. So this is all the aspect of how we are created based on these rules that sit inside of data and inside of formulas. Could I have a show of hands? Who here can tell me what this is a photo of? Anyone? So I put this through a computer vision, the Microsoft Computer Vision API, and it said that this is a close-up of a logo. That was kind of the best that the artificial intelligence could get from that image. What about now? Anyone recognize it? Yep. A castle? King's Palace? White House? Buckingham Palace? So what's going on here? This is coming back to the keynote as well. The answer that you're giving is based on your context and your experiences. So Buckingham Palace, maybe, do you come from England? You do? And the White House, a famous... Are you the President of the United States? And then the AI here is now saying it's a close-up of some grass. It's getting a bit more context, but it still doesn't know what it's looking at. Now, if I take it one step further, this is a photo I took on Monday of the presidential palace in Oslo, just up the road from here. And the AI now sees it as a large white building, which is contextually correct. And then if you do a reverse lookup on the location itself, it is the Royal Palace in Oslo. So the reason for showing you this is really an example. The artificial intelligence and the data systems we have are only going to be as good as the data that we can provide into them. If we don't have enough data or there's no clarity in the data, the machines aren't going to help us much come up with the answer. So it's really around having enough information to then use the human intelligence to provide the context to deliver the solution. So Hollywood would have you believe that the future is made up of this idea of machines taking over the world. They'll talk about Terminator, they'll talk about the mass unemployment, the loss of jobs. Now, some of that is based on paths that we are travelling. But I think the future is more going to be about the idea of humans plus machines. And the future is a place where for people who can master and improve situations with machines. Humans, we have understanding. Machines have calculations. Humans have purpose. Machines have instructions. And humans have passion and curiosity. And machines have objectivity and lack of bias. And we're moving into an era where an amateur plus a machine plus a better process is actually superior to an expert plus machines plus an inferior process. So if we think about I was at the Lightning talk with Dave Christensen just earlier today, and he talked about his setup for brewing beer, where he has a Raspberry Pi, and they've built a whole brew kit which can measure the gravity in the water and create the whole automation process for brewing. And I was thinking about that, and I was thinking an amateur brewing beer plus that kit and a defined process could potentially be producing better beer than an established player who doesn't have those techniques, who are working from experience alone. The best example of this that I can think of was actually in 2005, where these two guys, Zach Stephen and Stephen Crampton, did something quite remarkable. This was the world's first freestyle chess tournament where there were no rules in regards to how you could participate. You could use computers, you could use machines, you could create a group of people to play together. And these two amateurs, who weren't ranked in the top 500 players in the world, won the tournament with the use of 3 PCs coming from New England, completely unknown. And what they managed to do that nobody else could do, they beat grandmasters, they beat great computers like Deep Blue, and they did it by changing the approach and changing the technique. They'd spent 4 years studying what moves would potentially be played by those other systems, and then built a database to actually change the response and perform the calculations on the fly in response to which techniques the machines would apply or the grandmasters would apply. And they won this tournament at the surprise of basically everybody in the world who didn't know where they could come from or how they could achieve that. Anyone familiar with Kaggle.com? There's a few hands. So when I was learning machine learning and teaching myself how to build machine learning models, I found Kaggle.com as an amazing resource, because it's one place where human experience plus machines is really creating solutions for the world. What happens at Kaggle.com is companies give you all their data and then create a competition for you to solve their problems for them. And then the wisdom of the crowds, people will come in, try and solve the problems, and then produce what we call notebooks with their solutions, and then they'll iterate on each other's ideas to get the best solution. And there's cash prizes for the person who can solve the problems in the best kind of way. And it's just a great way to get together to add that amateur plus or professional plus machine approach to learning. So a few years ago, I was on a stage not that dissimilar to this, and I was talking about data being the future and all software companies are going to become data companies. And I felt like a bit of a fraud because I didn't have my own example. I didn't have my own story, and I hadn't experienced any of this for myself. I was a software engineer working in C#. I didn't know any of this stuff. So I was feeling like, okay, this might be the future, but it's not a future that I know, and it's not a future that I can own. And at the same time, I was a bit dissatisfied with my current state of being. I was a bit overweight. I had spent a lot of time in front of a computer. I wasn't very active. And I developed a condition called vertigo. So I was constantly quite dizzy, and I spent a lot of my time feeling like I was slightly drunk, which was, an unpleasant situation. Not bad enough to make me really want to do something about it, but bad enough to be frustrated in the situation. And then that continued on for a number of months, and I thought, okay, well, I'll go and see a doctor and see what's wrong with me. I went and got an MRI scan. I went through all the medical process, and there was nothing wrong with me. So then I went and saw a physiotherapist, and the physiotherapist said, well, your problem is that you spent more than 10 years hunched over a computer 10 hours a day building software. And you don't have enough exercise, you don't active enough, and you just need to improve your posture and start being more active. And as I took that advice and started to do that, the situation changed. And when I thought about this, I thought, okay, I'm thinking about a problem, a change problem. And to me, change is after something stops, something else begins, and that transition period between the two is change. So I thought about this in the form of a formula, which is the change formula. On the left-hand side, you've got your dissatisfaction with the current state, times by the vision of what you want to achieve, times by the first steps required to get there. And as long as these three things are greater than the resistance you put on yourself, change will occur. And since I've gone through that process, I've started to apply this to everything that I've been using. And the solution I'll take you through later is a great example of this. I chose to code it all in Node.js because I'm really comfortable in C#, and I wanted to teach myself a new technique and new skills to do that. So I started with dissatisfaction. My love of craft beer, plus my bad diet and lack of exercise, was really what had led to my situation of dissatisfaction in the first place. The vision of what I wanted to achieve, I figured I'd come up with a goal that was absolutely impossible. Well, impossible to me, because at the time I couldn't run or walk more than a kilometre. I was very unfit, and it was around the middle of 2013. And I thought, you know what? I'm going to run or walk 4,000 kilometres in 2014, which was just crazy. There was something that I possibly, in my mind and minds, I thought, there's no way I can do that. So spoiler alert, I did do it. I did 4,041 kilometres that year. I set another goal in 2015, which was to do 5,000 kilometres, and I achieved that goal as well. And then last year, I set a new goal, which was to run an ultramarathon, which I achieved in February, which was 8 hours and 22 minutes during an ultramarathon competition. But enough on that. Like, coming back to the beginning, the first step. So the first thing I changed was my work environment. I got myself a treadmill and a standing desk, and I broke up my day between sitting and coding and standing and coding. And I found that by setting a low speed and walking, I was able to actually become more active and actually be active during my normal day. I started running on the treadmill. I managed to run a kilometre and then 10 kilometres, and then I started running outside. And I was on my way to achieve my goal. But this is, like in any story, this is where resistance kicks in. If you've heard of the hero's journey, there's always going to be a point where it gets too hard or something happens that pushes you back into the place where you began. And for me, the resistance was a big capital R. I became allergic to exercise. I contracted a virus early in 2014, and what I should have done is I should have stopped exercising when I had that virus, because that's the logical thing to do. But because I had this goal of the 4,000 Ks, I felt I couldn't stop. I had to actually keep going to achieve that goal. I exercised on the virus, and I developed an autoimmune disease with no known cause and no known cure, which is called chronic urticaria. And then from that day on, every day I went running, I broke out in full-body hives, and a couple of times I was actually hospitalized through my allergic reactions from exercise. So, as a resistance trigger, this was actually a pretty big one, kind of sat up there in the outcomes. But I managed to cure myself through insight from data, and that, to me, is the start of the story. That's where I learnt how I could understand the data of myself and then use that to cure the condition that I had. So the first step one, was track everything. I see Adam sitting over here. Here's a photo of Adam just after he gave his talk on the first day of NDC. You notice on Adam's wrist he's wearing 4 fitness trackers. So why 4, Adam?
I'm trying to transition off the band.
So this is the thing, like as engineers we want everything to be precise. And sometimes we'll move from one device to another and we'll need to feel like it's consistent. But I've got a view that, it's good enough. Like my journey with trackers, I started about 4 years ago with a Fitbit 1. I moved to a Microsoft Band. I moved to a Fitbit Surge. I moved to a Band 2. And now I'm using a Phoenix Garmin device. And there's pros and cons around each one. But when you do think about fitness trackers, I think the key thing is to make sure that you can get access to your data. Because some of the systems and ecosystems make it really hard to get your data out. And, I'm a firm believer that you own your data, and that if you're using a device to collect it, you should be able to extract it and you should be able to use it for the purpose that you want to achieve. And so Fitbit does that, but you have to pay to get access to it, and they don't provide all of the data that you need. Microsoft Band was very good at that, and Garmin is very good at producing the outcomes as well. The second one, learn how to breathe. Who knew that we had to learn how to breathe? Who knew this was a skill that we actually had to develop? I went and saw a guy called Dr. Sven at the Resilience Institute in Auckland. And he came up with this, he introduced me to this concept called heart maths. And it's based around the idea of using heart rate to adjust attention and focus. So when you're nervous or when your heart rate is running fast, you have this idea of chaos, which means that you lose focus and you're not operating at your best. And when you're relaxed and your heart rate is slowed, you have cohesion, so you can start to be more focused in approach. When I started applying this technique using breathing techniques, I actually got one of the ECG monitors on, and when I put that on, I was able to drive attention and meditation, and I could instantly control a robot using my mind, using the same techniques I was using for heart maths in mindfulness and focus control. And this was all new to me. It was something that I'd never done before and didn't have any experience with. The next part, learn how to eat. So this is my chart. On the left-hand side here, this is about the time when I got the virus. This is the period I had chronic urticaria. And this little point up here was the diet change. And so what I did at this point is I used a scientific experiment. I basically reset everything. I became a vegan, raw food, whole food, took everything out, took out caffeine, took out alcohol, and just pressed reset on everything. And then what I did is I started to reintroduce things one by one and measure the effect of reintroducing those foods like caffeine and certain foods. And I did that using body pH and also noting, like, if I ate a certain food, would my ears get hot or would it go red, and what were the reactions in my own body? Because everybody's different. So I figured you actually had to create a model that was based on the situation for yourself. So when I did that, I found out that I have a adhesion to caffeine, and that when I have caffeine and alcohol, I have a really high resting heart rate as a result. And at the time, my resting heart rate was up around 80, and I didn't really realize that that was not normal. And because I was running, I would go long distances and I'd have these little gels. And the problem is 80% of the gels you buy have caffeine in them. And so when I was having the gels, I was exercising with a high heart rate, and I was raising my heart rate even more into dangerous levels. So I realized that for me, actually giving up caffeine altogether was the best thing I could do. So about 3.5 years ago, I stopped caffeine, and I have had none anymore. And I stopped alcohol, but I kind of reintroduced that because I needed to reintroduce it. But what I was able to do with this technique was actually, within 30 days, I cured myself. And I'd gone from having this condition to not having this condition anymore. I lost a reasonable amount of weight at the same time, but then I could reintroduce things and go along with that process. So when I think about this in the terms of business intelligence and insight, the history of business intelligence is around hindsight. It's around the what happened, drawing meaning from what happened. It's why did it happen, the diagnostics, so you can avoid it happening in the future. And we're moving into this area of advanced analytics, where we talk about predicting the future, what is going to happen, predictive analytics. And then foresight is how can we make it happen by knowing what triggers and things are available, how do you adjust that to actually make a certain outcome occur? And this is the exciting world of human plus machine. So how many people here are runners or cyclists? Anyone keen runners or cyclists? Wow, a reasonable amount, maybe half the people in the room. So one of the things I discovered when I took up running was the site called Strava. And Strava is effectively the social network for runners and riders and athletes around the world. If you look at the last attempt to do Everest, it was live posted on Strava with thousands of followers watching every move as the heart rate and live data as people were going up towards the summit. It's also an amazing way of finding places to go when you go to new cities. I was first time in Norway, and I can say that Norwegians are crazy when it comes to distance running and cycling. I went for a run on Monday up around the lakes, and the amount of people out doing ridiculous distances and setting Strava records was something I haven't seen anywhere else in the world. But it's a great site because you don't want to build everything. Like, there is a good place where you can export your data to automatically, and you can draw insight through the programs and the networks that are already there. So if you see over here, this is when I started out. My fitness level was 10 out of, I don't know what it goes up to. And this was my training process as I started to measure my heart rate, VO2 max, recovery rates, all of the things that I was building as I was learning how to run. You see peaks as I was training towards events, and you see peak points of when I actually competed in particular events. And my fitness got as high as maybe 72, which is really elite athlete kind of material. And currently I'm running at around 52 on the chart. So this is a period of maybe 3 or 4 years that I've been operating on this. So it's a great place to actually look and to find. I also am on another social network called Untapped, which is the same version of social network for craft beer and for beer consumption. That's where I log all my beer data, and that's where it all feeds into the system as well. So this is my architecture of what I've built, and these are the components that I've put all together. So on the left-hand side, I have had previous data sources, as I mentioned, like Fitbit and other devices, but today my input devices are the Garmin watch, the Area wireless scales. Now those are Fitbit scales, so I actually get the data from them by going through an app called MyFitnessPal and then syncing that into my Garmin. So it comes out with my Garmin data because I would have to pay money just to get the Fitbit extract on the weight. And then Untapped is my beer consumption area. Inside here, information management. I'm using Azure Functions, and I'll take you through how I'm using those. Inside over here, I'm using a Cosmos DB. So who's familiar with Cosmos DB? There's a few hands. I hadn't used it before, and it really is a globally distributed document database. You can replicate it in different regions around the world closest to your users, and we guarantee a less than 10 millisecond or a single digit to the 99th percentile latency for calls, for read. And I think it's less than 15 millisecond for write. Now, obviously, that's not going to work if it's complex queries, but for basic querying, it will do that. And inside of there, I've used DocumentDB as my data repository. I've run machine learning and analytics over the top. So I've used Azure Machine Learning and Azure Search. Azure Machine Learning analyzes my data through the function each time it comes in and then predicts if I'm getting sick. and then notifies me as an early warning if I'm getting sick. So I often get sick after I travel. Like last time I went to Korea, I was sick on the plane ride. I got sick on the plane ride home, and I was sick the day after I got back. And I'm aware that when I travel, my process changes. I get tired, and I drink more, I sleep less, and all those other things. And I actually got a warning yesterday morning from my machine learning model to say, hey, slow down. I think you're getting sick. And I chose, to come home after the boat trip last night instead of go to the pub. And I was feeling like a bit of a sore throat this morning when I woke up, and I wasn't feeling 100%. So I actually had a preemptive warning from my model to say, no, it's going to go that way for you. So a great example. And, it's been maybe a month and a half since I last got a warning from the system. And then over here, intelligence. So Lewis is the Microsoft language understanding. I'll take you through that. The bot framework. So this is for building bots that can run on cross-platform. So the bot framework is a single location where you can publish out to, like Slack or the web or Facebook Messenger, Skype, and you can create a single bot interface which can then get published out into those different areas. Personal digital assistant, so Cortana integration, and then dashboards and visualization through Power BI. So that is the system. It happens to be a full Microsoft system, but it was also technologies and areas that I didn't have any experience with that I wanted to learn with the data model that I've got. So with that, I'm going to come out of the slides and I'm going to take you through what I've built. So show of hands, how many people have used Azure Functions or familiar? So good, maybe half the room here. For those who haven't, it really is there's a few models. You can have a triggered function, so you can trigger it by calling it through an API or calling it through the browser, or you can have this area which is timer-based functions. So I've got a function here, which is a timer function, and inside of this timer function, if I run on the monitor, it runs once every hour, and what it does when it runs every hour, it last ran actually an hour ago, is you'll notice over here, it connects up into Garmin, and it pulls out my current active data from my watch throughout the day. So this data here, I think coming through is the 15th, so it's today's data, and this is my current data, and as the day is continuing. And at the same time, it calls out to my published machine learning model, which then uses that data to predict, it pulls in the untapped data to check how many beers I've been having, and it also pulls in the weight data, and then it checks whether it thinks I'm getting sick or not and logs that inside of the document database. Inside of the one thing that I noticed when I was running this is that there's a couple of places where you have to do configuration. And so, because I hadn't published a Azure function before, I'd written it in Node and I had it running inside of VS Code, and then I wanted to publish it out as an Azure function. And so when I did that, I couldn't really figure out how to, bring in the libraries, run the npm install. But then what you do is you can come in here under the platform features, and there's an area here called Advanced Tools, Kudu. And then when you open this up, there's a debug console. And so you can load the debug console, and then you can navigate into the site location. And here's the site location, so you could then do your npm install, and it would load all the modules that you wanted to bring in to operate within your function. So it would set up those directories for you. And same thing with NuGet if you're using C# version of function. And that was one thing that took me a little bit to figure out. The other thing that took me a bit to figure out was how to do the keys. Like I needed my database key, and I needed my Garmin APIs and things like that inside of there. And it's just here in app settings, again, under the area over on the right. You've got your application settings, and then as you scroll down, I'm not going to show you my keys, but just down here, there's a value pair. So you can put a name on the left and your key on the right. And then you can access that using the same approach that you would otherwise use. So over in my function, I can then get it using process.env.dbkey. And I thought, like, I was trying to put a process.env file in there and to put them in, and it wasn't working, and so that was just a bit of a learning that I got. When you run the function, so there are ways to debug Azure Functions locally, so you can actually create a local instance and set it up. But what I find is it's a little, like what I found was easier was actually running it inside VS Code as a local node file, and then actually doing it that way and then processing it up into the function after I had done that, and just using console to read it out. So when I press run, that's actually going to go away and run that function, starts the function, it goes and performs the operations and outputs the output on the right-hand side of as it's doing it. So it should have just run through and processed and delivered the outcome. Once that updates, over here is my document DB. So this is Cosmos DB. And inside Cosmos DB, these are all of the locations where you can replicate your database to be close to the individuals who are using it. Obviously, there's a cost involved, so you don't necessarily want to replicate it everywhere if you don't need to replicate it everywhere. So for my example, I've just got it sitting in West Coast USA. I haven't actually got it replicated in any other particular locations. Inside of my collection, there's my database. And inside my database is my data. And if I have a look here, you can do simple queries against the data. So here's some data objects. If I wanted to just grab a query, say, of the last few days, this will give me the last few days for my data over here. So if I run this one, there's my data from the 13th, from Tuesday, in a document format with my stats coming through. There's my data from the 14th. It's my data from today that's being updated throughout the day. Now, I find this is actually a really good way of whatever data you're collecting through whatever disparate systems or wearables, you can automatically export it, get it into the format that you want, and have it in a centralized location that can then become really useful for doing other things out of. So if I stop wearing this garment and get something else, I can continue to use this and have consistency on my data going through. So it's a pretty nice way to do that. The next thing I've done is I've actually wrapped Azure Search over the top of it. And the reason for doing this, like, I thought, well, why do I do that? Do I want to call directly into the document DB, or do I want to put a search layer over the top? And the reason I put a search layer over the top was so that I could create match some queries for when I wanted to call it through from the bots that I was building. So over here, you'll see that it's got an index and that it runs once an hour. So once an hour it'll run over the top of my document DB, update its index, and then have a new view of the data that I can query in against. It last ran 5 minutes ago. And inside the data, you'll see down here, I've created, based on the types of the data that's there, some of these things are filterable and retrievable, some are sortable, and I can query against different things like vigorous intensity minutes is essentially where I'm exercising hard. Moderate intensity is when I'm kind of breaking a sweat but not going hard out. So I've been able to put all of those things in there and then run different models against them for my search indexing. And so then over here, I can actually perform search queries against my data in a normalized form. So not everything is available in regards to OData search. So some of the date functions aren't implemented just yet. So you have to do things like between this date and this date to get last month, for example. So that will give you last month's data. And you notice because it's cached and running through the index, it's very fast in returning the objects and the information. From there, before I move to the next step, I really have two endpoints for my data. So when I first did this, I was using Power BI, which is Microsoft's intelligence insight environment. So if I go on to powerbi.com, there's a data set that I created over here. So if I go into data sets, there's this one here, which is called data of me. And this is connected when I look into the settings over here. Oops. Oh, it's over there. Where is it? I'm sure that there was an approach there. But anyway, what that's done is that's connected up against the document DB. So there's a preview connector for Cosmos DB, Document DB into Power BI. And you have to set that up using the Power BI desktop client. But once you've set that up, you can then access it inside of here. So what this is automatically doing is it's every hour? Yeah, or maybe not, every few hours, it's then updating the data from my document DB into my data set in Power BI. And so then if I come into reports, I've created some custom reports for the data of me. And if I was to edit these reports, you notice the size of them is kind of this card kind of size. And the reason for that is that when I look at that page, it's set up to be page size is for Cortana. So that means that it can integrate down. I've turned on the question and answer format and the Cortana integration inside of the data set. It's just a checkbox on the data set so that it can then integrate back into Cortana. So I could then say something like distance traveled 2015. And then what that will do is it will call into my model over here and it will filter it based on 2015. So over here I went 5,026 kilometres in 2015. These are the data and the information. It's broken down, so I've got, April, Saturday, there's the amount, the average of the distance. And if I click on a particular one over here, this is a day in April where I went 44 kilometres and was really active for 272 minutes, did 128 flights of stairs. So that was, a big event that I competed in during that particular time. I could do things like I could say, okay, what about beers, 2014? And this is when I was going through and changing my diet and adjusting and finding out the change in activity. So you'll notice here, 572 beers that year. This number going up over here is the minutes I'm really active. So this is when I'm doing a lot of exercise. This is my weight over the year, dropping down. And this is me going no alcohol in October and bringing it back slowly in November, the month after. And so you can start to see where the trends happen, where the things are coming through. If I did that for 2015, oops. You get the idea, 2016. So you can start to draw insight and get feedback from what's going on. Now, one of the things, oh, wow, what's that? June, Saturday in June, lots of beer. Yeah, ridiculous amounts, and then me kind of turning a corner. Oh, it put my weight up too, look at that. I was quite, oh yeah, who knew? Who knew drinking lots of beer made you put on weight? So you can learn a lot from the information there. And what I was also learning was around heart rate, because heart rate became really important to me. So when I was looking at 2015, these were where I had my numbers, because you always have some numbers that you're working towards. So I didn't have VO2 max in 2015 because I hadn't started on Strava and I didn't have a device that was actually recording VO2 max. So I've got missing data for that. I had a minimum weight and a maximum weight. So, there was, and then I had a maximum heart rate, minimum heart rate. But if I moved that to like last year, I was able to see that, I started to get my VO2 max and track my VO2 max as a key indicator. So by having those key numbers and being able to track them and looking at them, through dates and days of the week, I was getting a lot of input and feedback. The thing I really liked about the Power BI approach was that there's also a dashboard. You can ask questions of your data. So I could come into my dashboard and I could see the little charts over here, and I could ask questions like, what was my distance travelled in January? They'll give me a little chart for that. I could do free flow questions. So essentially, like, what was my average sleep in 2017 by month? Noticed I had a lot of sleep in January, and then this is this year. So as the year's gone on, I was not actually ordered by that, it's ordered by the amount, but you see this month I'm around 7.2 hours a night. In January I was way up there. So you get that kind of approach of how you adjust. But the thing is that not everyone's got Power BI, and I found that Power BI, there's a license aspect to it, and there's component aspect to it. So what I really wanted to do was actually take the Q&A features out of Power BI and apply that to a bot. So I could get it when on Facebook Messenger or Skype or web platform or different approaches that I was having. Now, I did some research and I found out that you can't actually do that very easily. The Power BI question and answer isn't exposed as an API, so you can't really take what's been done over here and apply it over there, which is why I had to go down the route of using Azure Search. And then what I was able to do is I was able to build the bot around the concept with Azure Search. So I'm going to show you two things first. Just before I go to the bot, I'm going to show you the machine learning and how I built the model that can predict if I have the virus. So inside of Azure Machine Learning is where I went away and trained the system using 4 years of information that I had captured and fed into it. And so this is my data at the top. And when you look at the data set, if you visualize it, is pretty consistent. You get some insight from it. So, the calories burned, distance, floors, minutes very active, calories, weight, heart rate, beers, virus. And so what I've also did was I needed to label my data because I had to tell the machine what it looks like when I'm sick. So I just kept a note of every time I got sick, and I could apply a label to that inside my data to say, yes, I was sick. Because if the machine has never seen what being sick looks like, it's not going to be able to interpret when you get sick. So for a few years, I started tracking and logging every time I was getting sick. And then what I had inside of there was the columns that I could select. So these became my classifiers. So I used most of the data that I had. There were a couple of things I threw out. I didn't think weight was terribly important. Weight kind of fluctuated, but I left it out of my model because it didn't move terribly quickly. Like the weight between one day and the other was pretty insignificant. I took max heart rate out for the same reason because it didn't really feature. I took distance out because I had steps, and steps was basically correlated to distance, so they were pretty much the same thing. And I took date out because I included days of the week because I thought that was more relevant than the actual date itself, because the date itself didn't have terribly much context, in my opinion. And then I labelled it by making it categorical. So I said day was actually categories, so Monday, Tuesday, Wednesday, Thursday, Friday were categories, and virus was a category, which was yes or no. And then I scored it based on virus. And if you're new to Azure Machine Learning, there's a website which gives you this Azure Machine Learning algorithm cheat sheet. Because the thing I studied statistics at university, but I'm not a statistician, and I'm not an expert when it comes to the algorithms and what to choose for doing the machine learning side. So what I was able to do is I went in and I had a look at this cheat sheet and tried to figure out what was the best algorithms to use the data to approach for this. So I've got a URL I share at the end which has got the cheat sheet on it. And what I realized is that for my case it was probably a two-class classification. So the two-class classification was, do I have a virus or don't I have a virus? It could have been a regression, an anomaly detection, because sometimes there's lots of data with nothing, and then occasionally you'll see something different which is used for credit card fraud and things like that. So it could have been anomaly detection, or it could have been two-class classification. Those were kind of the two areas I wanted to look into. I used both, but I got a better response out of the two-class classification. And then inside here, I tried a couple of the algorithms. I tried a two-class decision jungle and a two-class neural network and a boosted decision tree. And then I scored those against my data to determine which one worked best with the information that I had. So to show you how to do that, inside here in Azure Machine Learning, you can drop in the different algorithms. So there's a two-class neural network over here. There's a two-class decision jungle over here. And then what you can do is you split your data. So I said, okay, let's take 70% of my data and use that to train the model. And then 30% of the data will be held back for scoring the model. So you essentially train on 70% and score on the other 30%. But the key thing is to actually also make sure that you have a stratified split. Because you want examples of having a virus in both sets of data, in both the data you're training on and also the data you're scoring on. Because if all the examples of viruses are in one side and not the other, your model's not going to work the way you would expect. And then from there, you can score the model, and then you can bring it back together and evaluate. So when I ran this through with the data, you can actually run this again to retrain the model. So as more data comes into the system, periodically you can retrain your model, and then you can republish your web services off your retrained model so that it will learn over time as opposed to just be a fixed point in time. But you don't have to do it all the time. Like it's something maybe you do once a month or after a spate when you have, where I got sick again. And now it kind of comes back here, and the one on the left is the model on the left, the two-class decision tree, and the other one is the decision jungle. And so if I was to choose this one over here, anything over that grey line down the middle is better than flipping a coin. Because basically that grey line down the middle is 50% chance of getting it right or wrong. It is essentially random. So anything up around the top end of the curve is a high degree of confidence. And so when I look at this one here, when evaluated, it had 4 true positives, 1 false negative, 1 false positive, and 200 true negatives. I don't have a lot of examples of when I'm sick, and that's part of the problem with this. Is that you need more data. It's coming back to the blurry photo before versus the sharp photo. The less information you have, the effectiveness of your model is kind of is adjusted. And the other model had more false equations. So when I went into the other model, I think I had, false negatives 3. So it was quite accurate, but it didn't do any false positives, and it actually only had false negatives. So it was not the model I wanted to use because it didn't deliver the outcome that I was expecting. So from there, once I trained the model, I can publish that as a web service using a predictive experiment. And so once it's published, you then have an endpoint that you can work with. So over here, this is just testing the service, feeding in a bunch of data on the left-hand side, testing the response. So this is my data from yesterday. And you'll notice down here, it said, yes, I think you do have a virus, and I'm 64% sure that you do. So this was the trigger that actually notified me to say, hey, slow down yesterday. So based on this information fed in, which was I wasn't, very active at all. I didn't travel a lot, terribly much distance. But I had a really high resting heart rate, a couple of beers, and that had gone away and said, yeah. So what's interesting is if I increased my number of beers and then tested the response, let's try that. It's now saying, no, I don't have a virus because you had 8 beers, and you know what? 8 beers raises your resting heart rate, so therefore I'm no longer thinking you're sick, but I'm 32% sure that you're not sick, if that makes sense. So there's a chance you could still be sick, actually quite a high chance, but I think based on the number of beers, I don't think you are. So that's the kind of learning and the logic that comes through from the system, and it happens automatically. It happens without you needing to think, to load, and to call it, you essentially just call the web service inside of the function or inside of the bot, and the data will come back from there. The next part was actually how do you wire that up? How do you build a bot? So let me show you the bot. So the bot here, this is the bot running, and I can say how many beers did I have this week? Had 11 beers this week. What was the most beers I had this week? Drank 5 beers on Tuesday, June 13. Okay. What was my... And those are Norwegian beers too. That's a lot of money. There's a deposit on a small house. What was my... I could say, what was my highest resting heart rate this week? 57 beats per minute on Wednesday, June the 14th. 57, yeah, that's pretty high. And then I can say, when did you last predict that I was sick? Wednesday, June the 14th, I predicted you were sick with 64% confidence. So that was the trigger that came out. And I could say, when did you last predict that I was unwell? And the reason it's understanding is because I'm using the Lewis model for natural language processing. So it's taking what I'm writing and it's interpreting it, and then it's returning that in a form that I can then call my Azure Search with. So, and then I could say, when was I last sick? For example. So I was sick on the 5th of May, and it was 92% confident that I was sick on that day. And when was I sick? In January this year. And there is when I was sick in January. So on the 6th, it was 99% confident. On the 5th, it was 91% confident. On the 7th, it was 99% confident. And then on the 8th, when I was actually getting better, I thought I wasn't sick with 58% confidence. So it was kind of working it out and adjusting it as we went along. Now, this is really interesting because when you look at Lewis, the way that Lewis works is it builds the interface for the natural language inside of the bot and turns it into the entities and the entities and activities that you can program against to call the search query. So over here, this is all the calls that I've got against the bot, and predict is quite high, and last is quite high, and some of those numbers as they run through. But what you'll be able to do is there's a whole bunch of things that are built in. So the best one that's built in is this idea of pre-built, which is date time v2. So what that does is that actually says, so if I look at Lewis over here, and I could say, when did I last go for a run, for example? Not when did I last go for a run. Let's ask it something like, how many beers did I have last week? Last weekend. So what it's done here is it's said, okay, I think you're trying to get Garmin data. I think you're talking about beers. I'm 99.9% sure you're talking about beers. I think you're looking for a count because you've said how many. So I'm 97.5% sure you're looking for a count of beers. And you said last weekend, and this is using the pre-built date time range thing. So it said, okay, last weekend was the 10th of the 6th to the 12th of the 6th. So that gives me the dates that I can then run against my Azure Search query. So I can build, so what I'm actually doing inside the bot framework is I'm actually building my queries for Azure Search based on the outcomes of the Lewis intent data. And so, for example, if there was something like, if I said to it here, when was the last time I went for a run? So I'm saying, when was the last time I went for a run? Sorry, I don't understand when was the last time I went for a run. It's because that particular utterance isn't interpreted or loaded into here. So when I go into here and I look at intents, and I see suggested intents, suggested utterance. This is what, when people are calling your bot and it's not making matches or it's not actually returning what you think it should be, and you can come over here and you can actually find the ones that are in use, and you can apply them. So if I was to go into here and say and put that same statement, it's now actually loading that one up and predicting the utterance from it, and then why is it? It's taking a moment. And then it can actually interpret that, and it can understand. And so when I was retrain that model, it would then know that, and it would be able to use that inside of the collection. So, for example, what would happen if you're working in languages? So over here, how many beers did I have in 2017?
Hvor mange øl hadde jeg I 2017?
Sounds like it's had a few beers as well. So if I take that statement over here, and then I run that against Lewis, I'll actually try it in the bot first. So I've asked it that question, and it said total beers to, whoa. Whoa. Oh, no, that's right, isn't it? Yeah. Gosh. And then if I look over here and I paste that into my Lewis query, you'll notice it actually matches the Norwegian word for beers against beers. And it's matching the count over here against count, and it's interpreting the date. And the reason it's able to do that is because I've come into here and I've created this thing called features, and I've gone into beers, and I've told it about the Norwegian word for beer. So it knows that word, so therefore it's able to interpret it, and it can use it into the model. Norwegian isn't supported as a language natively inside of Lewis yet, so you would need to do some kind of translation and run it through in English, or you would have to actually follow that approach of using features to bring it in. And then, so that's kind of the way that the utterances work. If I was to say, when did I last go for a run? I think it probably would figure that one out. Yeah, there it goes. Tuesday, predicted I wasn't sick with 100% confidence, so it was pretty sure I was well on Tuesday. So it's kind of gone through, and the thing I really like about this is that I taught myself how to use this over the last week, and I built this out over the last week as a precursor for giving this talk. But now I've found that I'm really keen to publish it. I'm really keen to actually have it at a point where I can start to use it. I was thinking I was going to publish it onto Facebook Messenger or Skype and make it available to everyone in the room, and then I thought, actually, I don't necessarily want you to know how much sleep I get and how much beer I drink, considering the talk's recorded as well. But the process to go from having it running inside of here and publishing and deploying is pretty straightforward as well. It's cross-platform, and it will, operate across a range of different, chat clients. So that's kind of it. That's how I've put the system together, how I'm building the components. I've got one more slide, which is some resources. The next step for me is to write it all up. Get the code, clean it up, put it on GitHub, write up the repository, and write up the blog post about how the pieces come together. So I'm going to work on that on the plane on the way home. I think I've got 36 hours on my trip back to New Zealand where I can start to put that together and make that available. The thing I will call out, the one at the top here, the Azure Search bot, I used that as a tutorial on how to do the Cosmos DB and the Azure Search and wire that up with the bot, and I found that a great way to learn. There's examples in both C# and Node for doing that, so you can follow that tutorial in either of the two. And I am using free versions of the Azure Search and Cosmos. I think Cosmos wasn't free. I think it was a minimum spec one. So you can do it, without spending a huge amount of money too. So with that, I think the time is up, and I'm happy to take questions and talk to people after the talk. So thank you very much.